I've opened up a new tab in Chrome, and we want to browse to dnspropagation.net. That's spelled DNSPropagation.net. This is a free service that will query a domain name from different DNS servers all around the globe. So here where it says enter your domain name, I'm going to put www.BenPiper.host and then click start. The value that Route 53 answers with is shown next to each DNS server. Note that our 4 different instance IP addresses all show up, so it's clear that Route 53 is returning each of the records. So we can be confident we'll get some kind of traffic distribution, but what's not clear is that the weighting itself is working. We could count up how many times each IP address appears, but that's cumbersome and frankly, ain't nobody got time for that. So guess what? I've created a PowerShell script to help us out and do the work for us. Let's jump back over to PowerShell. The script we're going to run is named dnstest.ps1. This script will perform a series of DNS queries for the domain name we specify and then display the responses along with a tally of those responses. The idea here is that it will show us a distribution of IP addresses so we can tell whether or not weighting is working. And here's how it works. First, I'm going to specify the host name, www.benpiper.host, followed by the primary name server of the zone, which I have conveniently on my clipboard here. Now, why the primary name server? Well, each time the Route 53 name server receives a query, it will run a process to decide which weighted record to respond with. This means each time the script queries the name server, it may get a different weighted record. If I were to use my local name server or a public name server like Google or OpenDNS, those name servers would cache the response for 30 seconds, and that would skew our results and make them inaccurate. All right, next we're going to specify the number of iterations, and we'll put 8 here. This is how many times the script will run. 8 is a good number here because we have 4 records, but remember that because of the somewhat random nature of weighted records, issuing 4 queries does not mean that we'll get 4 different responses. So by issuing 8 queries, there's a better chance that we'll actually get each record at least once. Finally, we'll specify a sleep time of 1 second. This is how many seconds the script will pause in between queries. There's nothing magical about 1 second. You could put 2 seconds or even 0 and it would work. Now remember the rationale I just gave you for not using my local name server. It would cache the responses for 30 seconds. Well, you could actually still query your local name server and just set the sleep time here to 30 seconds or a bit more, and that would overcome that TTL issue. But that would also cause the script to run for 4 minutes, and you don't want to wait for 4 minutes. So just querying the Route 53 name server directly and pausing for 1 second between queries will give us a quick result. Okay, let's run this. The script tells us how many times Route 53 returned each IP address. Notice that the percentages don't match up exactly with the weights we configured. This is normal. A single client querying multiple times will not necessarily get the exact weight distribution you configured. What's the point of it then? Well, if we were to run this through more iterations, say 16 iterations, we would get closer to the configured distribution. Let's go ahead and try it. I'll hit the up arrow and I'm going to change the number of iterations from 8 to 16. Notice how we're slowly converging on 25%. We're getting a little bit closer. All right, what if we double the number of iterations again to 32? Let's try that. I'm actually going to change the sleep time to 0 so we're not waiting as long, and the number of iterations is 32. All right, this looks pretty much identical to what we had before. Let's go ahead and run this one more time. All right, now we're getting very close. Now, this is a lot like tossing a coin. If you toss it 10 times, you may get heads 4 times and tails 6 times. But the more times you toss it, the closer you'll get to an equal number of heads and tails. The same thing applies here. Each record has an equal probability of getting chosen because they're all of equal weight. But let's say we don't want this behavior. What if we want, for example, the West Coast servers to get twice as much traffic as the East Coast servers. How will we do that? Let's talk about that.